heat sensing exhaust fan. In this Arduino-based project, we are going to build a temperature-controlled fan using thermistor. With this circuit, we will be able to adjust the fan speed in our home or offices according to the room temperature. To do this, we will be using an Arduino UNO board, one thermistor, NPN transistor BC547, and a DC motor with fan. To control the speed of the fan, we will use the PWM technique. Here is the connection diagram of this project. This is a thermistor. Thermistor is a type of resistor, whose resistance changes with its temperature. Thermistors are of two types, NTC, or negative temperature coefficient, and PTC, or positive temperature coefficient. We are using NTC type thermistor. In NTC type thermistor, resistance decreases with rise in temperature, so in this circuit, when the thermistor will sense the heat, its resistance will decrease. One end of the thermistor is connected with the positive supply voltage, and another end is connected with the A0 pin of Arduino. We have connected a 10 kilo ohm resistor between ground and A0 pin. This resistor will make the pin A0 ground, when thermistor will offer a high resistance. NPN transistor BC547 is used as a switch. Transistor has 3 pins, base emitter, and collector. Base terminal is connected with the Arduino. When the temperature at heat sensor is below a certain level, then Arduino will turn off the transistor, and transistor will cut the supply of the fan. As the temperature will increase, Arduino will increase the fan speed using PWM technique. This is the code of our project. First of all, we will take two integer type variables, x and y, void loop. This function continues to execute the code written inside it, over and over, unless we reset the Arduino hardware board. Thermistor is connected at pin A0 of Arduino, so we will read the analog pin A0, and store its value in the variable x. Its value can be between 0 to 1023. Fan is connected at pin number 11. We will control the speed of the fan using PWM. In PWM technique, we can use values only between 0 to 255. This function will scale the values of pin A0 from 0 to 255. If value of x is 0, then it will set the value of y to 0. If value of x is 1023, then it will set the value of y to 255. Similarly, if the value of x is 512, then it will set the value of y to 128. Analog write 11, y. This function will control the speed of the motor using PWM technique. Now write this code on Arduino IDE compiler. Then save the program. Now check the code for any error by pressing this check button. If code is correct, then upload it to the Arduino hardware board. For this, connect the Arduino board with laptop or computer using a USB cable. Now go to the Tools menu, and select Arduino UNO. Go to the port option, and select the port at which Arduino is connected. Then press this arrow button, to transfer the code to the Arduino hardware. Our code is now transferred to the Arduino successfully. Now we will assemble our hardware. First of all, we will connect a 10 kilo ohm resistor with the thermistor. Now connect a red wire at one end of the thermistor, connect a black wire with one end of the resistor, and connect a yellow wire at the joint of thermistor and resistor. Cover the joints with insulation tape, to avoid any shorting between its two terminals. Now we will take a DC motor and connect a red and black wire to its supply terminals. Now we will take a NPN transistor BC547, connect a black wire at its emitter terminal, and a green wire at its base terminal. Now we will connect the DC motor with the transistor. Connect the black wire of the motor with the collector of transistor. Now connect the red wire of the thermistor with the 5-volt pin, black wire with the ground pin, and yellow wire with pin A0 of Arduino. Now connect the red wire of the motor with the 5-volt pin, black wire of transistor with the ground pin, and green wire of the transistor with pin number 11 of Arduino. Now we will power up our project and test its functionality. We will use a lighter to provide heat to the thermistor. When the temperature goes above a certain level, then fan starts running. As the temperature decreases, the speed of the fan decreases gradually. When temperature goes below a certain level, then fan will turn off. Our circuit is working perfectly. I hope you enjoyed the video and learned something from it. For any help or to clear your doubts regarding your project, you can contact us on our student care number 7007957715. To buy the items used in this project, you can visit our website www.erroltech.com. You can give us the orders on WhatsApp also. Thank you so much.